Hello everyone, this is Sir Said. Hope you are doing well. First of all, please subscribe this channel. And the second thing is that we are going to discuss momentum, some basics of momentum, the relation of momentum, its unit, and the law of conservation of momentum. And at the last, we will solve one or two past paper questions. So let's start from the definition of momentum. In fact, we can say that the product of mass and velocity is called momentum. Means P is equal to mv. If you want to increase the momentum of the body, uh, uh, you have to increase the mass or the velocity or both. For example, a heavy truck is on the road, its mass is large and it's moving with some velocity, then its momentum is large, momentum is high because of its large mass. But as compared to this truck, if you have a small bullet fired from the gun, its mass is very small but its velocity is large. So in this case, the momentum is high because the velocity is very high. It means all the moving objects have some momentum. If the object has some velocity, it must have some momentum. It means this momentum is a vector quantity, vector, and its direction is same as the velocity have. It means the P and V have the same direction. And the unit is kg meter per second. And you may write it as from F is equal to MA. Unit is Newton, kg meter per second square. So from this relation, we may write kg meter per second as Newton second. This is second square. One of the second is multiplied on the other side, so we have Newton second is equal to kg meter per second. Means the momentum has the unit of Newton second. Next, if we have the law of conservation of momentum, this is important. And first of all, I'm going to show you a diagram which will tell you that how you will be able to solve the problems. For example, we have a mass m1 and this mass is moving with some velocity u1. There is another mass m2 moving with velocity u2. Just look at the direction, both bodies are traveling in the right side. And when these bodies are going to collide with each other, means they hit with each other, and during this collision both the masses exert force on each other according to Newton's third law. Anyhow, if this mass m1 is going to strike with m2, it means its velocity is greater than its velocity, means u1 must be greater than u2. Anyhow, after the collisions, these two masses start moving again in the same direction. For example, this m1 and m2 are again moving with the same direction. Now, uh, first of all, for this mass and velocity, the momentum is m1 and u1. And for this, the momentum is m2 and u2. For this, for the time being, ignore this thing because we are just going to discuss the momentum before and after the collisions. So after the collision, the mass and velocity is m1 v1 and the momentum is m1 v1, and for the other body the momentum is m2 and v2. So First of all, momentum is m1 u1 for this body, momentum m2 u2 for this body, momentum m1 v1 and m2 v2 for these bodies after the collision. So if we add the momentum of the bodies before collision and we add the momentum of the bodies after collision, then these values must be equal to each other. So it is the law of conservation of momentum, means the sum of momentum before collision is equal to the sum of momentum after collision. But one of the most important factor is that this is an isolated system. Isolated system means there is no external force acting on the bodies. Like sum of momentum before collision is equal to the sum of momentum after collision in the absence of any external force. In the absence of any external force means isolated system. It means momentum conservation is valid if we have an isolated system. So to solve the problems you must memorize this equation with this standard diagram, with this one. So if one of the direction is going to reverse, then you have to put a negative sign over there. For example, if this velocity is reversed, means the v2 is in this way, suppose, then put a negative sign at this place. And if for any other arrow is going to reverse, just put the negative sign. Okay, so on the next slide, this is a question. We have these two masses 2 and 4 kg. They are going to travel with 8 and 2 meter per second velocities, and then they collide with each other and stick together. Means we put the same formula here, that is m1 u1 plus m2 u2 is m1 v1 plus m2 v2. It means these two velocities are same. After the collision, v1 and v2 are same, so we may write it v because they are same. And this is now m1 u1 plus m2 u2, and here we have m1 v plus m2 v, and this is just v. So by taking v as common factor, we have this relation m1 u1 plus m2 u2. Now substitute the values. This mass is 2, the velocity is 8 plus 4 into 2, v is common, and the masses are 2 plus 4. So remaining portion I'm going to solve over there. 16, 8 divided by 6. So the answer is 4 meter per second. Option A is correct. The trick is that before collision the velocities are same, so we have the same relation, and after the collision they have common velocity, so it is easy to get the velocity as a common factor, and you can have this answer. For example, if we don't have the bodies going to collide and move in the same direction, we may have like this one. For example, this is a body, its mass is say m, m1 and it is moving with some velocity u1, and we have another mass m2 and it's moving with velocity u2, but they don't have the head-on collisions, means their centers are not going to coincide. It means after the collision they move in different directions, like this one and this one. They are not moving in a straight line because they don't have head-on collision. Their centers are in fact not going to coincide with each other. Like it is a mass m1 and this is the mass m2. Its velocity is say v1 and its velocity is say v2. Clear? So now we have to divide these velocities and in fact the momentums into their components. For example, this is the horizontal component, this is the horizontal component, and these are the vertical components. If these are the horizontal, means we must have angle over there. Say this angle is alpha, this is beta. So this is called m1 v1 cos of alpha. This is m2 v2 cos of beta. So now the relation is m1 u1 plus m2 u2 is equal to m1 v1 cos of alpha plus m2 v2 cos of beta. Means the sum of momentum before collision is equal to the sum of momentum after collision, but after collision we just take the components which are in the direction of the momentums of m1 and m2 before collision, and the vertical components are also equal and opposite. So this is m1 v1 sine alpha and m2 v2 sine beta. So this is equation 1, and equation 2 is m1 v1 sine alpha plus or equal to m2 v2 sine of beta. These two are equal and opposite, so put a negative sign with one of the momentum, and this is called equation number 2. In the latest papers, these two equations will help you to solve the problems in which the masses are not having the head-on collisions. In this whole lesson we just started from the momentum, the product of mass and velocity. It is a vector quantity, and if you want to increase the mass you have to increase the velocity, mass, or both. And in the law of conservation of momentum, the sum of momentum before collision is equal to the sum of momentum after collision, and external force is absent, means there is no external force. It is isolated system. That's why the momentum is conserved. And at the last we just learned about that if the bodies are not going to have head-on collision, then how we can get the components of the momentum after collision and how we can equate the momentums. Thank you very much.